Students, today let us discuss about analog output model part 2 lecture, and this is a representation of a basic representation of speed control of three-phase induction motor using a PLC or any controller. And here D200 is the data register, or it is a memory location of your controller. So in the memory location we will give some number. The number will be given to your controller. So that PLC, the number will be 1000, 12,000. It is a number, decimal number. That number will be converted into 16-bit binary value. That 16-bit binary value will be given to your analog output model. This model is nothing but it is an analog output model. This analog output model, it accepts the digital value, it converts the digital value into equivalent voltage. That voltage, it is in the order of 0 to 10 volt, or 0 to 5 volt, or minus 10 to plus 10 volt, or 4 to 20 milliampere. The output may be in the form of current or voltage. Anyway, it is converting a digital input into analog output. So that's why this model is known as analog output model, because the output of the model is analog. This voltage, variable voltage, or the control voltage, is given to control terminal of your variable frequency drive. So based on the voltage, the motor will run. So this table represents relations between the PLC data registers value and your speed of your induction motor. Suppose in a register, if I supply 0 number, then the equivalent by digital value will be 0000. This value will be given to analog output model. If the analog output model will produce 0 volt, so it is the unit of this number, the data is volt. So 0 volt is given to VFD. The machine will run at 0 speed. If I pass 1600 in the data register D200, then the CPU will convert this decimal number into equivalent binary value. The binary number or digital number is given to analog output. It will provide 1 volt. If I apply 1 volt, then the machine speed will become 150. Similarly, if 3200 number is given in the data register, the PLC converts this decimal into binary. Binary goes to analog output. Analog output run the VFD run the machine 300 RPM. Similarly, if 16,000 is given, the 16-bit value all become 1. So your analog output will produce 10 volt. So your machine will run at 1500 RPM. Let us see the animation. Suppose if I pass 0 in the data register D200, your CPU will produce equivalent binary of 000000. So your analog output model, so this is your analog output model. It takes the binary value, it converts the binary into equivalent analog. So it will produce 0 volt. If I apply 0 volt to VFD, the machine will run at 0 RPM, or it won't run. If I pass 1600, equivalent binary will be created and it is sent to analog output. Analog output will produce 1 volt. 1 volt is given to VFD. So if I apply 1 volt, then the machine speed will become 150 RPM. If I send 3200 number, then this is the binary. That binary is given to analog output. Your analog output model will produce 2 volt. So your machine speed will become 300. If it is 4800, this is the binary. Binary is given to analog output. So 3 volt will be generated from the analog output. If I apply 3 volt to VFD, machine RPM will 450. 8000, then the machine output will be 5 volt. So the machine speed will become 750. If I apply 16,000, then 11111, if I apply 111 to analog output, it will produce 10 volt. If I apply 10 volt to VFD control terminal, the machine speed will become 1500. This is how your controller or your PLC or your microcontroller controls the induction motor speed. So we will discuss the various type of analog output model in our next lecture. Thank you.